Hey everyone, welcome back. In this episode, I'll show you how to train your own image classifier, starting from just a directory of images. For example, say you want to build a classifier that can tell the difference between a picture of a T-Rex and a Triceratops. Or maybe you want to classify a painting as being a Monet or a Picasso. To do that, we'll work with a code lab called TensorFlow for Poets. And this is a great way to get started learning about and working with image classification. Now, two things off the bat. First, this code lab is high level. To train our classifier, we'll basically just need to run a couple of scripts. But what's impressive is the classifier we'll create is better than what I could have written myself just a few years ago. As we go, I'll show you how the code lab looks in action, and I'll add context and background on why it works so well. Okay, let's get started. To train an image classifier with TensorFlow for Poets, we'll only need to provide one thing: training data. Here, that's just directories full of images. My plan is to create a classifier to tell the difference between 5 types of flowers: roses, sunflowers, and so on. And here's what my training data looks like. Notice that I have 5 directories, one for each type of flower. Inside each directory are lots of pictures. And the reason I'm working with flowers is we provided this data set in the code lab so you can get started right away. If you want to use your own images, say for dinosaurs or paintings, all you need to do is create a directory and fill it with images from the web. We'll need about 100 images in each directory to start. Once we have our training data, the next thing we'll need to do is train our classifier. And for that, we'll use TensorFlow. TensorFlow is an open source machine learning library, and it's especially useful for working with a branch of machine learning called deep learning. Deep learning has led to great results in the last couple of years, especially in domains like image classification, which we'll be working with today. And here's one reason why. Recall that way back in episode 1, we talked about telling the difference between apples and oranges. We saw it's impossible to do this by hand because there's too much variation in the world. But now we also know that classifiers take features as input. And with images, it's incredibly hard to write code to extract useful features by hand. For example, you wouldn't want to write code to detect the texture of a piece of fruit. To get around this, we use deep learning because it has a major advantage when working with images. And it's this: you don't need to extract features manually. Instead, you can use the raw pixels of the image's features, and the classifier will do the rest. To see the difference in how our training data looks, let's compare the iris dataset with our directories of images. In iris, each column is a feature that describes the flower. And you can imagine we came up with these features manually, say by measuring the flower with a ruler. Now, by contrast, here's our training data in TensorFlow for Poets. It's just a list of labeled images. And again, a classifier is just a function, f of x equals y. Here, x is a 2D array of pixels from the image, and y is a label like rose. Now, when we're talking about deep learning, the classifier we'll be using is called a neural network. At a high level, that's just another type of classifier, like the nearest neighbor one we wrote last time. The difference is a neural network can learn more complex functions. In this code lab, TensorFlow for Poets takes care of setting up and training the neural network for you behind the scenes. That doesn't mean that TensorFlow code is any harder to write than what we've seen so far. In fact, my favorite way of writing TensorFlow programs is by using tflearn. And tflearn is a high-level machine learning library on top of TensorFlow, and the syntax is similar to scikit-learn like we've seen so far. For example, here's a code snippet that shows you how to import a neural network, train it, and use it to classify new data. And you can do this using the skills you've already learned. If you want to learn more, no pun intended, about this stuff right now, I put links in the description you can check out. Okay, now let's return to TensorFlow for Poets and train our classifier. To do that, we'll kick it off with this script. It's covered in detail in the code lab, so I won't say too much about it here, but I will give you context on 2 more things you might want to know about. First, the script takes about 20 minutes to train the classifier. Now ask yourself, is that a long time? The answer turns out to be no. Under the hood, TensorFlow Poets isn't actually training a classifier from scratch. Instead, it's starting with an existing classifier called Inception. And Inception is one of Google's best image classifiers, and it's open source. Whereas we have just a couple thousand images in our training data, Inception was trained on 1.2 million images from 1,000 different categories. Training Inception took about 2 weeks on a fast desktop with 8 GPUs. In TensorFlow for Poets, we'll begin with Inception and then use a technique called retraining to adjust it to work with our images. This lets us reuse some of the parameters Inception has previously learned so we can create a new high-accuracy classifier with far less training data. I'll fast forward till our training finishes, and once we have a trained classifier, we can try it out. To do that, I'll download this image of a rose from Wikimedia Commons and use our classifier to predict what type of flower it is. As we can see, it gets it right, and we can see the confidence distribution for the other types of flowers as well. Now keep in mind our classifier only knows about the training data we've shown it, so if we ask it to classify an image, say of the Roman Colosseum, it must predict that it's a type of flower. Hopefully though, the confidence will be low. Now let me give you 1 or 2 more closing thoughts. To train a good image classifier, the name of the game is diversity and quantity. By diversity, I mean the more images of different types of roses we have, the better off we'll be. For example, our training data includes pictures of red, white, and yellow roses. We also have pictures taken at different angles, say from above or to the side. And we've included pictures of roses in the foreground as well as the background. Now by quantity, I mean the more training data we have, the better a classifier we're likely to create. There are several hundred images inside the roses folder. That's enough to retrain Inception, and you can probably get away with even fewer images, though your accuracy might decrease. Okay, that's it for now. As a next step, you'll probably want to dig deeper and try writing your own TensorFlow code. Here's a link to a tutorial that will show you how to do that, and you can use exactly the same technology we saw here. As always, thanks very much for watching, and I'll see you guys next time.